Ever wondered how the electricity that powers your devices is actually produced and transmitted? Let's delve into the intricacies of electricity. At its core, electricity is all about the movement of electric charge. This charge is generated by the push and pull between electrons and protons, the building blocks of atoms. And when these charges move, we get what's known as an electric current. This current doesn't just appear out of thin air, though. It's generated in power plants through a variety of methods, including burning fossil fuels, harnessing wind, or capturing sunlight. From there, it's transmitted across vast distances through a network known as the grid. Imagine the grid as a massive interconnected web, delivering electricity from power plants to homes, schools, and businesses alike. This complex system ensures that the charge generated in a power plant miles away can power your device right here, right now. Understanding how electricity is generated and transmitted is the first step in grasping the world of electronics. What do you think are the tiny parts that make up your favorite electronic devices? These minute parts, known as electronic components, are the backbone of every electronic device you use. Each component has a specific function, and their collaboration results in the device's overall operation. Let's start with resistors. As the name suggests, resistors resist the flow of electricity. They limit the current flowing through a circuit, protecting other components from potential damage due to excessive electric current. Next up, we have capacitors. These components store electrical energy temporarily, releasing it when needed. Think of capacitors as mini batteries within your device, holding onto energy and letting it out when required. Then there are transistors. These tiny powerhouses are the workhorses of modern electronics. They control how much current flows through a circuit. You can think of them like a faucet, controlling the flow of electricity, much like a faucet controls the flow of water. Diodes, another essential component, only allow current to flow in one direction, preventing potential backflow of current which can harm the circuit. Like a one-way street, they ensure that electricity travels in the right direction. Inductors, on the other hand, resist changes in the current flowing through them. They're like the steadfast friends who don't like sudden changes, ensuring a steady and consistent flow of current. And let's not forget about integrated circuits. These are complex circuits shrunk down to fit on a tiny silicon chip. They can perform an array of functions, from acting as microprocessors in your computer to amplifying signals in your radio. These are just a few examples of the numerous components that make up an electronic device. Each one has a role to play, and it's the harmony of these components working together that brings your electronic devices to life. So the next time you're using your smartphone or playing a video game, remember the small world of resistors, capacitors, transistors, and more working tirelessly inside your device. These components, when assembled together in a specific manner, give birth to the gadgets you use daily. Did you know that electronics is divided into two broad categories, analog and digital? This division is not just a matter of semantics. It fundamentally impacts how electronics function and are used in our daily lives. Let's take a closer look. Analog electronics are those in which current or voltage changes continuously over time. This means that the signal variations are smooth and seamless. They're like a flowing river, where the water level can be anything between its lowest and highest points. Think of things like the old school radios and televisions or the vinyl record player. These devices use analog signals to produce sounds and images that are rich and detailed, capturing the nuances of the real world. On the other hand, digital electronics operate with signals that have discrete values. It's a world of ones and zeros where information is processed in binary form. If analog signals are like a flowing river, digital signals are like a staircase with clearly defined steps and no in-between values. This simplicity makes digital signals more resistant to noise and easier to process. It's the technology behind most of our modern devices, from smartphones and laptops to digital cameras and smart home systems. So while your record player uses an analog signal to perfectly capture the subtle variations in a song, your smartphone uses digital signals to process millions of instructions per second, allowing you to browse the internet, take photos, play games, and much more. Of course, it's not always a case of analog versus digital. Many devices use a combination of both. For instance, a digital camera captures light using an analog process but then converts it into a digital format for storage and processing. Whether it's the old vinyl record player or the latest smartphone, analog and digital electronics form the backbone of these devices. As we continue to innovate and create new technologies, these two types of electronics will continue to play a critical role in shaping our world. Ever seen a weird diagram with lots of lines and symbols and wondered what it is? Well, you're not alone. Those cryptic drawings are actually the heart of electronics. They are called circuit diagrams or schematics. Let's start with the basics. An electronic circuit is a path in which electrons from a voltage or current source flow. It's like a city map, where buildings are replaced by electronic components and roads by connections between them. Now representing these circuits visually is where schematics come in. A schematic diagram is a way to represent a circuit using symbols for each component and lines to show the connections between them. Think of it like a language where each symbol has a unique meaning. For example, a simple straight line often represents a wire, while a zigzag line stands for a resistor. The difference in symbols is vital as it tells us about the function of each component. Just like a city map tells us whether a building is a hospital or a school, these symbols tell us whether a component is a resistor, a capacitor, or a transistor. But how do you read a schematic? Well, it's pretty simple. You usually start from the left, which is typically where the power source is located, and follow the lines to the right, which is where the power is consumed. The lines represent wires or connections, and where they intersect, it implies a connection between components. So, what's the significance of these symbols? They allow us to understand the functioning of an electronic circuit without having to physically see or touch it. You can look at a schematic and understand what the circuit does, how it does it, and even how to build it yourself. It's like reading a recipe where you understand the ingredients and the steps to make a delicious dish. Although they might look intimidating initially, schematics are just visual representations of electronic circuits. So next time you come across one, don't be scared. Just remember, it's a language, and like any language, it becomes easier to understand with practice. How can a tiny chip control a multitude of functions in an electronic device? You may find yourself wondering this as we delve into the magic of microcontrollers. These tiny powerhouses are integral to the world of electronics, acting as the brains behind the operation, controlling and coordinating the functions of various devices. Microcontrollers are essentially mini computers integrated on a single chip. They consist of a processor, memory, and input-output peripherals. The processor is the heart of the microcontroller, executing the instructions. The memory stores the program code, and the peripherals allow the microcontroller to interface with other components or devices. What makes microcontrollers truly magical is their versatility. They can be found everywhere, from your refrigerator controlling its temperature to your car, managing the engine's efficiency. They're the silent workers, making our everyday devices smarter and more efficient. But how do they do it? Well, it all starts with a program. Microcontrollers are programmed using languages such as C or Python. This program dictates what tasks the microcontroller will perform, how it will interact with other devices, and how it will respond to different inputs. The program is written on a computer, then transferred to the microcontroller using a programmer or a development board. Once the program is loaded, the microcontroller starts executing the instructions, one after another. If it's controlling a fan, for example, it might check the temperature every few seconds and adjust the fan speed accordingly. If it's in a digital watch, it could be keeping track of the time and displaying it on the screen. Microcontrollers are like a conductor leading an orchestra, ensuring each instrument plays at the right time to create a harmonious symphony. They monitor and control other components, making decisions based on their programming and the data they receive. In essence, microcontrollers are the epitome of the saying, "Great things come in small packages." They may be tiny, but their impact on the world of electronics is colossal. They've revolutionized the way we interact with devices, enabling automation and enhancing efficiency. Microcontrollers are like the brains of electronic devices, controlling and coordinating their functions. So next time you use a device, take a moment to appreciate the magic of the microcontroller inside it. So, what does all this mean for you? Well, let's distill it down to the most important points. We've journeyed through the intricacies of electricity, unveiled the role of various electronic components, and decoded the differences between analog and digital signals. We dove into the world of circuit design and schematics, and marveled at the magic of microcontrollers. Each of these elements forms a vital part of the vast and intricate world of electricity and electronics. Understanding the basics of this field is not just about satisfying curiosity or pursuing a hobby. It's about comprehending the underlying principles that power our modern world. From the smartphone in your pocket, the refrigerator in your kitchen, to the traffic lights on your commute, electricity and electronics are at the heart of it all. Next time you use an electronic device, remember the complex world of electricity and electronics that powers it.